In my previous video, I already talked about multicast filtering or IGMP snooping in general and IGMP query. In this video, let's directly jump into the topic about IGMP forwarding and multicast router port. In this video, we will discuss how UniFi switches or multicast routers do the IGMP forwarding and data forwarding. We will talk about what router port and member port are. At the end, we will discuss STP and the router port. Let's consider this very simplified scenario. So we have two switches. We have one multicast video source and two multicast video receivers. At the same time, we have two hosts which do not want to receive the video. If we do not have the IGMP snooping enabled for the multicast packet, the switch will forward a copy of the packet into each of the interfaces and other switches which are connected to it. This behavior works well for broadcast packets that are intended to be seen or processed by all connected nodes. For example, the host A and host C, right? But the packets will be flooded into the network even though for these two nodes, they have no interest in receiving the packets. Even though these hosts will rarely have any processing overhead to filter packets addressed to unrequested group addresses, the problem is they will be unable to transmit new packets for a period of time when the multicast packet is flooded. So the bandwidth of the network will be wasted. However, if you have the multicast filtering enabled, the switch will be smart enough to only forward the copy of the packets to the hosts which are interested in receiving them. It will not forward the packets to this host B and host D. But how the switch knows how to do that? How the switch knows which port it should forward the packets to, which part it should not. So now it's time to talk about multicast router port. This is my lab environment. I use 3 UniFi switches. The Pro 24 is closest to the UniFi gateway. Then 2 other switches, the small PoE switch and the Enterprise 24 PoE switch. They are both directly connected to the Pro 24 switch. So it's a very simple topology, right? And at this moment, if I go to settings, networks, you can see this type of multicast filtering setting. So I only enabled the IGMP snooping for default network. And I defined the IP addresses for the 3 switches so that the Pro 24 will become the querier, because it has the lowest IP address, okay? And at this moment, I do not have the multicast router ports configured. Everything else is default, okay? I have a Mac which will act as a multicast source and 2 other Mac machines as receivers. Because these 2 UniFi switches, they are connected to the Pro 24. I have 2 separate Wireshark computers which will be monitoring the corresponding uplink port. At the same time, I'm running Wireshark in each video source or receivers. Totally, I have 5 Wireshark sessions. In this way, I will tell for each individual port noted in the diagram what will be happening. Okay, let's see at this moment what's the port situation for the 3 UniFi switches. SSH into the 3 switches. Then go to the CLI mode. Okay, I mean, for the first switch, the Pro 24, let's see this 3 ports situation. Port 15 connected to the host, the Mac computer, 11 to this switch, and 25 to another switch. Let me run this command. So what I'm saying is, show me the multicast router interface information for the port 15. Show the VLAN related information. Remember, we only enabled IGMP snooping for default network, which is VLAN 1. So let me run this command. Okay, see, it has nothing, which means this port 15, there's nothing special about it. It's not a router port. Then run the same command for the other two ports. 11, nothing. 25, nothing. This is expected because we haven't configured any port for the enterprise switch. Run the similar command, but for port 1 and port 26. Okay, for the port 1, nothing expected. Then 26. See, interesting. It shows VLAN 1. So let's put it aside, move on to the small PoE switch. Then we can come back. For the small PoE switch, let me run the same command for port 1 and port 8. For port 1, nothing's there expected. See, we see similar result as the enterprise switch. It shows 1. So if you check these two lower part SSH session together, you can see they have the similar result for the uplink part. They are both showing VLAN 1. Why the system treat these two parts differently? Now it's time to talk about multicast router part. Let's use Wireshark to find out what IGMP messages are going on when the system is in pretty much idle mode. Let me start monitoring in the 5 Wireshark sessions. You can see all the 5 sessions, they are very quiet, and you may notice I filtered the display to help us to focus on the messages we are interested in. Now you can see for all the 5 sessions, they received the same information, the same packet. It is a general membership query sent from the very first switch, which is the Pro 24. Why this switch send out the general membership query? Because it is the querier in this network environment. So now from the multicast source machine, which is this session, let me start the video multicasting. So I already selected one of my own videos, start playing. Okay. You can see now from IGMP messages perspective, for all the 5 Wireshark sessions, nothing new is captured. Why? Because we don't have a multicast receiver yet. So let me start the very first multicast receiver, which is this particular computer. Open the RTP streaming. Open. Okay, the streaming started. Minimize it so that we can see what's going on in Wireshark. You see different behaviors in the 5 Wireshark sessions. So from this particular multicast receiver, you see this membership report from this particular client. It makes sense because it is itself which acting as a receiver, right? Of course, it needs to send out the membership report. But let's see which part received that membership report. Not the part which is connected to the multicast source, not the part which is connected to another multicast receiver. It is received and only received here. Which part is this Wireshark monitoring? Port 26. Only this particular part received a copy of this membership report. In this demo environment, only this port 8 and the port 26, they are the so-called router port. This particular membership report message is sent to this switch, and on this switch only this part is the router part, so only this part forward the message to the first switch, which is a IGMP querier. Only the IGMP querier needs to understand the membership information. To understand the IGMP implementation in UniFi switches, you may want to read this RFC 4541. By the way, this is just some recommendations to switch vendors. It's not really a standard, but it can still help us understand the implementation. Here, this RFC mentions IGMP snooping is separated into a control section and a data section. The so-called IGMP forwarding is for the control section. A switch should forward IGMP membership reports, which we just saw in Wireshark, only to those ports where multicast routers are attached. So to put it another way, the switch should not forward IGMP membership reports to the ports on which only hosts are attached. So to understand this statement, let's go back to our lab environment. Remember, in our testing, only this particular part for this switch forward the membership report to the first switch. According to the RFC we just examined, this switch is supposed to use this part. Why this part? Because this part is attached to the other multicast router, which is the querier. So this switch is supposed to forward the membership report to it. No problem, right? And it's not supposed to forward the membership report to other hosts. For example, for this particular switch, when it receives the membership report, it is not supposed to forward the message to, for example, this host, or to forward to, for example, this switch. So this switch is not supposed to forward the membership report to this host. So that's how we can understand the behavior we observed in the testing and related to the RFC. But one thing you may remember, in the UniFi network settings for IGMP snooping, it has this option to configure multicast router ports. So we just said, okay, for this test environment, this part and this part, the two green parts, they are the multicast router parts, right? But we never configure them. How the system knows these two parts are the multicast router parts? Then it comes to dynamic router part or static router part. So for example, let's use this simplified example. Because these two switches are linked using this cable, right? So the second switch will receive the general query from the first switch. Let's assume the first switch is the querier. The second switch will receive the general query through this link. So the second switch can automatically mark this particular part as a router part. So this router part will be the dynamic router part. The system can smartly enough to determine it. So that explains why in our 3 SSH sessions, we only see the port 26 and the port 8. They are marked here for VLAN 1. So basically when we run this command, show IGMP mrouter VLAN for port 8, it returns 1, which means for port 8, for this switch, a multicast router is attached. It's the first UniFi switch. And which network it is for? It is for VLAN 1. That's how we can interpret this command and this return. Having talked about IGMP forwarding, now let's discuss data forwarding. So now I don't have any multicast activities going on in the lab environment. In the 3 SSH sessions, let me show you the current multicast forwarding database. So the command is show MAC address table multicast. Okay, this is the current database content. Yes, it has a IGMP related entry, but just by reading this MAC address, I know it has nothing to do with our video, so we can ignore this existing entry. Then run the same command in the other two switches. For the enterprise switch, it's empty. For the small PoE switch, it's also empty. So now let me go to this multicast source Apple machine to start the multicasting. Before that, let me relaunch the Wireshark monitoring. By the way, I already changed the display filter to UDP because now we are going to examine the data packets instead of IGMP messages. So let me start capturing. Okay. Now in different windows, you may see different UDP packets, but they have nothing to do with this video, so ignore them for now. Now let me go to this multicast source machine. Let me start the multicasting. started. From this particular machine's Wireshark, you can see this type of UDP packets flooding. It's from this particular Mac machine sent to this multicast group which I specified. But from all the other 4 Wireshark sessions, you don't see the same packets. Why is that? Because we don't have any multicast receiver yet, and we have the IGMP snooping enabled. So that's why the switches, they will not flood the interfaces with the UDP packets, because nobody really need them at this moment. Right? If we go back to the SSH session to run the same command to see the multicast forward database. So from the first switch, if I run the same command, nothing. And second switch, nothing. Third switch, nothing. This is expected because there's no multicast data forwarding needed at all, right? Then go back to the Wiresharks. From this multicast receiver, let me start streaming. Play. Okay, now from Wireshark, what's the difference you observed? So first, from this client machine, we see the same UDP packets, right? So the switch, this particular switch, is forwarding all the data packets to this receiver. Why? Because this receiver needs the data packets. That's how the IGMP works. The other things you can see for this Wireshark, it is also showing the same UDP packets. What is this Wireshark session? It is for this particular parts. It's monitoring port 26. So why port 26 also gets this UDP packets? Because the multicast source is connected to the first switch. The first switch forward the data packets from port 25 to port 26, and then the second switch will forward the UDP packets to this receiver. That's how the packets are forwarded. But from the other 2 Wireshark sessions, you can see they are quiet. They are not receiving these UDP packets at all. At this moment, if we go back to the SSH sessions, run the same command for the first switch, see the difference? So it has a new IGMP entry. This MAC address is for the multicast group we specified. So this is for the multicasting we are doing now. And see, it is IGMP. The type is dynamic, and see this information, the forward port is 25. So which means for the first switch, it's forwarding and only forwarding the data packets through this port. You may ask, why not the port 11? Port 11 is also connected to another switch, right? The reason is from the other switch, there's no receiver. Remember, we only started this receiver, not this one, right? So that's why the first switch is not forwarding the packet through the port 11. Then if we go to the second switch, run the same command, see now the table is not empty. So for the same MAC address, the multicast group, it is forwarding data through 2 ports. The port 1, yes, it wants to receive the data packets. Of course, the packets need to be forwarded to it through port 1, right? But why port 26 also received the forwarded packets? Because anyway, it's not a member port. It is a router port, right? If we go to this RFC, it mentioned the data forwarding rule. For a data packet, it needs to be forwarded according to the group-based port membership tables, which means it needs to be forwarded to the member port and must also be forwarded to router ports. That's why you can see our router ports also appear in the multicast forwarding database. Then if we go to the third switch, the same command returns the empty table because currently for the third switch, there's no receiver active. Okay, then go back to the Wireshark sessions. Now from this receiver, which is this window, let me start the streaming. Open network, RTP. Okay, open. Okay, you can see it's receiving the same data packet now already. Minimize it. All the 5 Wiresharks, they are busy now. They are receiving the same data packets from the multicast source. So you may ask why all of a sudden the final Wireshark is also receiving the UDP packets. See, this Wireshark is for this part. port 8. For this new receiver to receive the packet, the first switch need to forward the packets to the port 8, and then the third switch can forward the packets to the receiver, right? It makes sense. If we go back to the SSH session, for the first switch, run the same command to show the database. See, it has a change. It's the same entry, but it has a new forward port, which is port 11, right? For this one, because it's connected to the third switch. Then for the second switch, so nothing's changed. Of course, for the second switch, nothing should be changed. Then the third switch, yes, now it has an entry. It's not empty anymore. And it has two forwarding ports, port 1 and port 8. As you can see, I indicated in the diagram, all the yellow ports, they are the so-called member ports. They will receive the data packets which are forwarded to them through the router ports or through the multicast source. Okay, I believe now it's clear about what's router port, what's member part, what's IGMP forwarding, and what's data forwarding. Okay, we just discussed how the switches can dynamically determine the router ports and the member ports. But if you go to UniFi Network Controller, you can see this option. So you can manually configure multicast router ports. This is the way to define static router ports. So you may have some special needs. For example, you have a device you want to attach to a port to receive all the IGMP membership messages just for troubleshooting purpose. You can define that particular port as a static router port instead of relying on the switch to dynamically determine whether it's a router port or not. So let's simply test it out. Let me go to this function. So I need to choose a switch. This switch is the second switch, the enterprise PoE. I'm good with that. For example, if I want to configure the port 8 as the static multicast router port, I can go to the setting here and just enable it and choose the default network, save it. That's it. So that's how easily you can configure a port as a static multicast router port. So then to test whether it works or not, let me connect a Wireshark computer to this port 8. From the network controller, you can see for the enterprise switch, the port 8 is configured as a static multicast router port, right? If we go to the second switch, the enterprise switch, if I run this command, show IGMP Snooping multicast router VLAN 1, now it lists two ports. Before this static port change, it only has port 26 because it's dynamically determined because it's connected to the query switch. That's why it's determined as a dynamic router port, right? But 8 was newly added because of our manual change in UniFi Network Controller. So we see the configuration change from backend. Let's see what's the real world effect. Let's go to Wireshark. So on the screen, I show you 3 Mac machines. I'm going to use the first one to act as a source, multicast source. The second one as a multicast receiver. And this one is connected to the port 8. We just defined it as a router port. Before the manual change, the port 8 for the enterprise switch shouldn't receive the membership report, right? Because it's not a router port. But now let's see whether it will receive it. Start the monitoring first in all the 3 Wiresharks. By the way, now I already filtered all the 3 Wiresharks using the desired filters, so you will only see the related IGMP messages. Then from the first window, let me start the multicast video source. Okay, it started. And then from the second Wireshark machine, let me start the multicast receiver. After it's started, a membership report is supposed to be sent out from this particular machine. Let's see whether it will be received in the right side as well. Started. See, it sent out a membership report to this group, and in the right side, we receive it. because now port 8 is a router port, so it will be forwarded with the membership report group as well. When it comes to the first Wireshark, because it is connected to the multicast source instead of the router port, so that's why it didn't receive the same membership report message. Okay, this is just a short demo to show you the effect if you manually configure the multicast router port in UniFi network controller. Okay, move on to the last topic of the video, STP. When we discussed the router port, we said, okay, port 8 for this switch, port 26 for this switch, they are the multicast router ports, right? Not sure whether you thought of STP because these two ports happen to be related to STP as well. In fact, the IGMP's implementation needs to consider STP. In this lab environment, I just connected another cable. So from the port 13 of this first switch, I connected a second cable to the port 16 of the enterprise switch. So now there are two links between these two switches, right? And to avoid the loop, STP will disable one link. And it will disable which one? This new one, because the old one had faster speed. So let's validate it. From the UniFi network controller, if I go to the first switch, the Pro 24 switch, I can see this 13 is showing green, but not showing any downlink device. And the port 25 is showing is connected to the enterprise switch. But if we go to the enterprise switch, see, for port 16, it says it's blocked by STP. And the port 26 is showing fine. It is connected to the Pro 24 switch. This is expected, regular situation. And we can check the current router ports for the two switches in SSH. For the first switch, the Pro 24 switch, let me run this command, show IGMP Snooping multicast router VLAN 1. Okay, it is not showing any port as router port, which is expected. For the first switch, we don't have router port. But for the second switch, the enterprise switch, run the same command. Okay, we have the port 8 just because we manually configure it so, right? But 26 is dynamically decided. We don't see port 16, even though 16 is connected to the first switch. It's disabled by STP, so it's not considered as a router port at this moment. But if I simulate a disconnect for this link, I manually unplug the cable. So this link should become active automatically thanks to STP, right? Then let's see whether our router port will be automatically reconfigured. So let me manually unplug this cable. Okay, as you can see, the port 26 is grayed out and the port 16 is green and is enabled, right? If in the enterprise switch, we run the exact same command again, see, it automatically reflects the STP change. Okay, it's sweet and simple. This ends this video. Thanks for watching.